Okay, here we go. So, I already kind of talked about this in the warm-up, okay, about factoring and stuff like that. So, when it comes to factoring, and we're going to be talking about using the greatest common factor as a way to factor here, because there are different ways to factor, okay? But this is a particularly good one. This is like a good place to start because it's useful in a lot of different places, okay? So again, remember, if we think about all the factors of 24, okay, those were 1, 2, 3, 4, 6, 8, 12, and 24, right? We talked about that in the warm-up. And then we also talked about all the factors of another number. I just picked at random, and it was 18. Okay, and 18, its factors were 1, 2, 3, 6, 9, and 18. Okay? And you can see a lot of common factors. Yeah, I told you when you came back, you can go. The common factors of 18 and 24, we talked about this too, right? So we had the factors of 24, the factors of 18 listed out. The common factors of 18 and 24, well, they both can be divided by a 1. They both have a factor of a 2. They both have the factor of 3. And they both have the factor of 6. Okay? And so then the greatest common factor, which is what we will refer to as GCF for short, because it's a lot to say. The greatest common factor of 18 and 24 is 6, right? Now you can see this is kind of a bit of work because we have to first find all the factors of 24, then we have to find all the factors of 18, and then we have to decide what's the biggest number that's shared between both of those. And that's a lot of work. But that's not the only way we can do greatest common factor, okay? That's not the only way we can do it. So let's start out here with something like, let's start out with something like, let's ask another question. Let's find the GCF of 9 and 36. Okay, and don't worry, we'll get back to polynomials and stuff like that in just a second. But for right now, we'll just worry about this. Okay, let's just worry about this. So here's a strategy that you can use to help you. You guys ever remember using factor trees? So like you take 9 and you ask yourself, what number divides 9? So what number divides 9? 3. Okay, so we'll break 9 down into 3 and 3, right? Can 3 divide any more? Can we break down 3 any more? Not by whole numbers, right? 3 is what we call prime. You guys remember that, right? It's only divisible by itself and 1. So we'll just say 3 is that. And of course, this 3 also won't break down any further. So in other words, 9 is equal to 3 times 3, right? That's easy enough. Yes. Mm-hmm. Okay, so that's pretty easy. Let's look at 36. Okay, what can divide 36?
9.
Okay, 9 does. It's 9 times 4, right? So 36 breaks down into 9 and 4. And then how does 9 break down further? 3 and 3, right? Can we break down the 3s anymore? No, right? So we're going to circle those because that's as far as they can go. Okay, what about 4? Can we break down 4 anymore? 4 is divisible by what? 2, so it's 2 and 2, right? And those also can't break down anymore. We can divide them by 1, but they don't get any smaller, you know what I'm saying? Like they stay the same. But I see what you're saying. Okay. So far, any questions on what we're doing here? Just to make sure we're all feeling all right on this. Is this familiar? Have you guys used this like little tree thing before?
Yes,
No, never. Oh, they all have. Oh, okay.
They've used it in 6th grade, and
Okay.
7th grade, and
Okay.
9th grade. Yes,
All right.
They have used it many times.
Caden, question.
Yeah.
Will we be able to use calculators on this?
So, yes, of course, like help you figure out like what divides and all that.
Yeah.
Yeah. So, and there is a command too. I can show you guys that as well. Do you know the command? Okay, I'll show you the command too. All right, so let's say 36 then. Okay, so 36, that's going to be, and I'm going to put them in numeric order, so it's going to be 2 2s, 2 3s. So 2 times 2 times 3 times 3. Okay, so what this is called the prime factorization. We rewrote 9 and 36 as a product of primes. Every number has a unique product of primes that it breaks down into. Okay? So these are all factors, right? These all divide. But now we're looking for the greatest common factor. So let's look for what's in common. What is shared between the 9 and the 36 for the factors? What can we pair up? Okay, there's a pair of 3s and another pair of 3s, right? All right, is there anything else to pair up? No, right? There's nothing left, right? The 9's already taken up there. So we have one pair of 3s and another pair of 3s. And what does that make? 3 times 3 makes what? 9. So the GCF of 9 and 36 is 9. Okay? The greatest number that divides 9 and 36 is 9. Okay? Questions on any of that? Okay, let's try it. Oh, question, Hannah.
What if there are other factors of 36 possible, like 1, 36?
Yes, correct. But if you list out all those factors of 36 and all the factors of 9, which would be 9, 3, and 1, okay, the greatest common factor, the one that's going to be shared between both of them, the largest one will be 9. So this is a technique to find that greatest common factor. What you're talking about, listing all the factors, this is not a technique for that. This is just to find the greatest common factor. Okay? So let's do one more here with just 2 numbers, and then we'll start throwing some variables in too. Find the GCF of 28 and 40. Okay, find the GCF of 28 and 40. So again, let's take our factor trees here on the 28 and the 40. So I'll write the 28 right here. Okay. Anyone see what can we divide 28 by?
4.
Okay, 4. Yeah, so 28 is 4 and 7. Okay. Does 7 break down any further?
No.
No, 7 is prime. So we have to stop. We circle that one. Can 4 be broken down any further? 2 and 2, right? And so I'm going to break that down to 2 and 2, and I'll circle the 2's because they can't break down any further. So you only want to circle numbers that are, prime, that don't break down any further. All right, let's look at the 40. Okay, what can we divide 40 by? Let's go to Alex. Alex, what can we divide 40 by? Alex.
40 by
2. So it's 2 and 20. 2 cannot break down any further. Dylan, what can we break 20 down by? 2. Okay, and that's going to give us 10 then. 10 can still break down though, right, Dylan? Dylan, what can we break 10 into? Dylan, what can we break 10 into? 2 and 5. And those both can't break down any further. So in other words, 28 is equal to 2 times 2 times 7. And 40 is equal to 2 times 2 times 2 times 5. Okay? Ben, do we have anything in common here? Okay, 1 pair of 2's. Anything else? Another pair of 2's. Anything else, Ben? No. Okay, so our GCF will be 2 times 2, which is 4. Okay, so the GCF of 28 and 40 is 4. Okay? The greatest number that divides both 28 and 40 is 4. That's the GCF. Okay? Questions on any of that? Bless you. So let me show you what we're going to be doing then, how we're going to use this kind of technique with polynomials. Now, I showed you this method of finding the GCF first because I think it's like, not the simplest, I don't know. It's the most straightforward way, I guess, to do it. Okay, it's the most straightforward way. There is another method I will show to some of you if you would like. Okay, later after we feel confident with this, though. Okay, I just want to make sure because I find this one to be the most generally useful. All right, so let me throw a problem at you now with variables in it. Okay, let's say we want to factor 16p to the fourth plus 4p cubed using the Gcf. Okay, so we have a polynomial now. In fact, this polynomial has two terms, so we would call it a binomial. Thank you for saving me there. Binomial. Okay. What is the highest degree? What's the degree of this binomial? 4. Right. Highest powered term is 4. What's the lead coefficient of this polynomial? 16. So this polynomial is this polynomial in standard form? Yes. Highest power is first, and then your lower power is on down. Okay. Good. All right. So, well, we got to figure out the GCF of this 16p to the fourth and the GCF with the 4p cubed here. So what's the biggest thing that divides both of these? Well, let's take a look here. Okay, so I'm going to take my number 16. I'll break it down. So what does 16 break down to be? Or what can we divide 16 by? 4, okay. 16 is 4 times 4. Can 4 break down any further? Yeah, 2 and 2, right? And then this 4 also 2 and 2. Okay. Let's go ahead and break down the 4 while we're at it. Well, we just broke down a 4. It's just 2 2s. Like that. Okay, easy peasy. Okay, now we're going to expand these terms, these individual terms. We're going to expand the terms to help us then factor. Okay? So 16, we just said, was equal to what times what times what times what? 4 times 4. Well, 4 times 4, or all 4 2s here. We want to use the primes here. So all these 2s. Okay? So it's 2 times 2 times 2 times 2. But then we also have the p to the fourth. So what should I write after the 2s? Yeah, so p to the fourth, how many p's is that? It's 4 p's that are being multiplied together. So it's going to be p times p times p times p, like that. 4 p's. Okay? So 16p to the fourth, if we expand it, is 2 times 2 times 2 times 2 times p times p times p times p. Okay? 4 2's, 4 p's. What about 4p cubed? 4 will be what? 2 times 2, right? And then p cubed is going to be times what? How many p's are in p cubed? 3. So p times p times p. Okay, so far so good? Are you done with my clipboard? Do my numbers. Okay, so Shepard, what's shared between these factors here? What's shared here, Shepard? What do we have in common? Okay, a pair of 2s. Anything else? Okay, a pair of p's. Anything else? All right, thank you, Dylan. Shepard, anything else? Another pair of p's? Another pair of p's. That's okay, Dylan, I know. I was being general. Okay. Very good. So that's one pair of 2s, another pair of 2s, another pair of p's, p's, and p's.
Mr. Wilbon, will we always work this out? Like,
That's a lot of p.
you see how far you wrote out like the p's? We always have to write that out.
I will show you another method that does not require it, but for right now, I'm showing you this one because I think it's the most straightforward. It helps. It takes more, and I think it maybe makes things a little bit easier. I know it's more work, but I think it helps to like make things a little more straightforward. Okay, that's what I do this for. So the GCF is 4p cubed. So the biggest thing that divides both of these evenly is 4p cubed. Okay, so what does that mean? If I go to take 16p to the fourth plus 4p cubed, I can say this is equal to, oops, I'm off the screen. My bad. Sorry, there we go. Okay, yes. So like to the fourth, you could say like it's a quartic. Like what would that be? So like 16. So you wouldn't say 16p quarted or anything like that. That'd be weird. But I mean, you can talk about a polynomial. So like if you only have a cube term, then you call that a cubic polynomial. Okay. But with the fourth, you don't really say it. You could call it now a quartic polynomial. But like as far as like what do you mean as far as what does it mean for it to be to the fourth power or something?
Yeah, like four-dimensional shape.
Yeah, it's hard to think in four dimensions because when we think four-dimensionally, when we think dimensionally, we think, something that exists in our three dimensions and stuff like that, right? But because we think visually, right? And visually speaking, we can only really assess things in three dimensions. So it's kind of hard to understand what a fourth dimensional thing would be. But you can imagine it changes over time, like a three-dimensional object, it changes over time. That would be four dimensions then: length, width, height, and then time. But there's other, but that's, so yes, it's hard to represent visually a four-dimensional object.
Would a four-dimensional object be like a tree?
In a sense, I see what you're saying, because it changes over time and stuff like that. Yeah, I mean, you could think of it that way, yeah. But again, it's like a four-dimensional, again, so to represent, like when you see three dimensions, you see them all at once, right? It's like they're right in front of you, visually speaking. So to represent that in the same sense in four-dimensionally, you have to be able to represent the tree in all of its various stages from where it starts to where it stops, kind of thing, which is like, hard to imagine. But anyway, I don't know. That's beyond the scope of what we need to worry about right now, okay? What I want to worry about right now is how we're going to then factor this thing. So we are using the GCF. We figured the GCF was 4p cubed. Okay? So this 4p cubed is being divided. When I say factor, that's a division, right? We divide 4p cubed out of that 16p to the fourth. Well, if I divide here, look at what's left over. If I take out my 4p cubed from 16p to the fourth, what's still left behind? I have two 2's and a p. Well, what's 2 times 2? 4 times p would be 4p. Okay? Plus, if I take all these out here, there'll be nothing left behind. Right? But remember, when we take it out, I'm dividing. So when I divide all these out, I'm left with a 1 from left behind there. Okay? So this is dividing using the greatest common factor. Okay, that is dividing using the greatest common factor. We find the greatest common factor, we pull it out front, right, and then left in parentheses is what's left behind, the things that didn't get paired. So the 2, the 2, the p, 4p, and there's nothing left behind, so it's just a 1 because we're dividing there, so you're dividing by itself. You leave a 1 behind.
You have to remember that, because if you leave it out, then that makes a difference.
It's wrong, exactly. And folks, you're like, well, where is this coming from? Well, think about it this way. If I were to distribute this, right, if I were to redistribute this, right, because I have something in front of the parentheses there, if I redistributed, what's 4 times 4? Anybody? 16. And then p to the third times p would be p to the what? P to the 4. There it is, 16p to the 4, right? If I distributed the 4p cubed times the 1, well, it'd be just 4p cubed, and there it is. So what we're doing here is like the reverse of the distributive property. We are undistributing. And we're not undistributing a random number. We are taking out the greatest common factor so that there's nothing else in common between these two things. Okay? That's factoring using the GCF. Question? Can you wait? Because I think you need to see another example. Okay, we'll see, and then I'll let you go. Sky? You're good? Okay, did you want to go to the bathroom? Yeah. I'll let you go, Sky, because you've been answering questions. That's fine. Mark's been kind of silent, so I want to make sure he's okay first. All right, we'll get that. Let me get a problem here. Okay, we'll do that. Okay, let's do this one, Mark. Okay. Now, Mark, sometimes the numbers are smaller, okay? And it's not necessary to expand them out like we've been doing, okay? So if I go back, sometimes it won't be necessary. That's not the paper I was looking for. Where did I put it? Right here. Sometimes it won't be necessary to do this. You'll be able to look at it and see what the greatest common factor is. So, for example, Mark, in a numbers like this, it's just 6 and 3. What's the biggest number, Mark, that divides both 6 and 3? 3, right. Okay, so the GCF of 6n to the 5th and 3n squared is going to be 3. And how many n's do each of these have in common? They have one n, but they have more than one in common. This is n to the 5th. This is n squared. So how many total n's can we divide out from both? Two of them, right? This is an n squared and n squared. So we can take out 3n squared. Okay? So Mark was able to look at this and see what the GCF was without actually doing the work. Now, if we want to actually do the work, I'll show you here. We can take the 6 and break it down into 2 and 3. That doesn't break down any further. We can take the 3, and, well, that doesn't break down any further. It's just 3. Okay, and so 6n to the 5th is equal to 2 times 3 times n times n times n times n times n. And then 3n squared is 3 times n times n. Circle your pairs. Okay, like that. And look at what it is. Just like Mark said, it's a 3, an n, and an n, or 3n squared. So Mark was able to just look at it and see what's in common there. And so then, 6n to the 5th minus 3n squared will equal, well, we'll pull out that 3n squared, and then what's left behind from the 6n to the 5th? Well, Mark, if you divided a 3 out of that 6, what's going to be left? 2. And you took an n squared out of n to the 5th, what will be left? N to the what?
N to the 1.
Nope. You have n to the 5th, you took out n squared, so we're going to have left over n to the 3, right. Perfect. Okay? And then he took a 3n squared out, and so that's going to be minus 1 there, okay? Because he took exactly this amount out. So it's dividing, and he gets a 1 there. We're dividing by itself. Okay? So there it is factored. Just like that. Okay? You can also see it here, right? There's the 2 n to the 3rd. And then here, everything was factored out, so a 1 was left behind. There we just leave a 1. So there it is using GCF. There's factoring using GCF. Okay? Yes, you may. Thank you for helping. Questions on anything? Okay, let's try another one. One more here, and then I'll have you guys try one on your own. Let's factor 14a plus 21a squared plus 21a cubed. Okay? So again, some of you guys might be able to look at this and know what the GCF is just by looking at it. Okay? So, in fact, let's go ahead and throw that out to the class here. What's the biggest number that's going to... So there's 3 terms here, so you have to think about all 3 simultaneously. What's the biggest number that divides both 14, 21, well, and 21? 7. Not the same thing. Okay? Yes, the biggest number that divides all 3 of these is 7. What about the variables? What's the most amount of variables that I can take out from all 3 of these? How many A's can I take out from all 3 of these?
1.
Yeah, I can take out 1 from each, right? At most 1 from each, because this one's only got 1. This one's got a squared, but again, I can only take out 1 because I'm limited by this one. Same thing here. So in other words, my GCF here is going to be 7A, okay? So you can just like look at it and see, okay, so if I do that, okay, if I take out a 7A from here, if I take out 7A from here, what's going to be left behind? Divide 14A by 7A, what's left?
2.
Just a 2, because we took the A out, right? We took the A out. So 14 divided by 7A is just going to be 2, okay? Plus, if I take a 7 out of the 21, what's left? Divide a 7 out of the 21, what's left? 3. Divide an A from the A squared, what's going to be left? Just A, right. Divide this 21 by a 7, it's a 3 again, but divide the A from the A cubed, what's going to be left? a squared. Because we had a cubed, you take an a out, you only have a squared left over. Okay? So some of you guys can maybe see, Kendall? Yeah, you're getting this okay? Okay. So some of you guys can maybe see how you can do this mentally, right? How you can do it mentally without having to, you know, like do the work that I'm showing here. For those of you that are like, well, Mr. Wid, this did not make any sense. Let me just break it down here for you real quick. Take the 14 and take the 21, and, well, we don't need to do 21 twice, but I'll just write it out there. 14 is 2 and 7. They both cannot be broken down any further. 21 is 3 and 7. They can't be broken down any further, and, of course, the 21 is 3 and 7 as well. So take the 14a, and we'll call that 2 times 7 times a. Take the 21, a squared, and we'll make that 3 times 7 times a times a. And again, with the 21, a to the third, 3 times 7 times a times a times a. Okay, just like that. Okay? And look, once you expand it out, what's in common? So what's in common to all three of these here? Okay, so there's a 7 in common to all three, right? Just like that. And then there's an A in common to all three. Is there anything else that's shared between all three? No. Okay, Sky says no. We all in agreement with that?
Yes.
Yeah, okay, that's right. There's nothing else shared. So then, you can see my GCF here is going to be 7A. And there it is, 7A, right? What's left behind that didn't get paired up from the 14A? What's left behind was a 2, right? There's a 2 that didn't get paired up. 21A squared, what's left behind from that? 3A, right? So plus 3A. And then what's left behind from the 21A cubed? 3AA, which is 3A squared. You can see there it is. That's what we got. Okay. Guys ready to try one on your own? Okay. Reagan, did you have a question? I saw you talking to...
Oh, no.
You're okay?
Yeah.
Okay. Any other questions on anything? All right, you guys try one here. Try this one. Okay. So factor using GCF. Okay, and here we go. I'm going to have you try... 8x to the fourth plus 24x to the third plus 12x. Okay, I'll leave one of them up there so you can see it. Okay, so factor it using the GCF. So your final answer should look something like this, where you have the GCF factored out in front, and then what's left over inside the parentheses there. Okay? Say again? It's plus 12x. Okay, so give that a try. I'll come around and help. If you're stuck or you're not sure, you want me to check it too. Yeah, you're right. I'm just saying what's next. To what though? Because you only took one x out of that, so you still have x to the what left behind. You have x to the fourth. If you take an x out of it, you should now have x to the third. Right. 2x to the third. No, right there. Yeah, right there. Yeah, because you took that x out front. And then plus, now what's 24 divided by 4? 6. So you're right, 6. 6x to the, not 3. Yes, because where you took an x out. Okay, and then same thing. So what's 12 divided by 2? Good. Is 3, and then you took the x out. There's no x left behind that. So that's it. That's the answer. Okay? And you can check back by looking, is there anything else that you can divide from all three of these things? And the answer is no, right? Like 2, I can take a 2 out. I can take a 2 out. Can't take a 2 out there. I can take an x out. I can take an x out. Can't take an x out there. So you took out all that you could. That's the greatest common factor in front of you. Okay? Okay, let's take a look here then. Okay, 8x to the fourth. So that is, I'm just going to write it out here, okay? 2 times 2 times 2 times x times x times x times x. 24x to the third is 2 times 2 times 2, whoops, got ahead of myself there, times 3 times x times x times x. And then 12x is 2 times 2 times 3 times x. And so we have a triple of 2's, another triple of 2's. No more 2's, no more 3's that we can do it. We have one triple of x's that we can do too. So we have 2 times x, which is 4x is our GCF. And then what's left over? From the 8x to the fourth, we've got 2x to the third. From the 24x cubed, we have 6x squared. And from the 12x, we have, well, just a 3. And there's our answer. Okay? Questions on any of that?
Okay, I got like the same thing, but whenever you're breaking out the 8x to the fourth, wouldn't you need to add another 2? Because 2 times 2. Never mind.
Good?
Yeah.
But if she finished her thought, what would you say to that?
I would say if you take your 8.
Instead of adding it, it's not multiplying.
Right, exactly. It's times.
2 times 2 is 4 times 2
Is 8.
is 8.
So
But that's
3
incorrect.
2's multiplied make 8. Mm-hmm.
Yes, that's true, but that's not, okay, but it's 2 times 2, it's not 2 times 2 times 2. Even though there's
8 is 2 times 2 times 2.
Yes, but look at what you've circled up there.
Because there's this 2, there was only,
But you're multiplying 2 times 2, you're not multiplying 2 times 2 times 2.
correct. This is all count as one factor, so this all counts as a 2, all counts as a 2, and then all counts as an x.
Okay.
Because that's, we're pulling, it's shared between all three, so we're going to pull out 1, 2 from all three. We have another 2 we can still pull out from all three, and we have one x that can pull out from all three. Shared.
Now, why that confused me.
No, I see what you're saying there, and others, yes, I see what you're saying there, yeah. Okay? Now, let me show you this next step here. Let me show you one more thing. If you're like, this is too much work, but I can't just see it, Mr. Widmeyer. Like some of us maybe, like you don't like how this is so much work, and maybe you like look at this and you're like, I really can't see it though sometimes. Let me show you, let me give you one more option for those of you that maybe wants, one like little idea here about what we can do. Okay? So, here's what we're going to do. I'm going to write 12 x to the third. We'll do one example here of it. Plus 4x squared minus 8x, we'll say. Okay? So, and here's really, this is really what I did back in the day. This is what I did, and this might be the most easy for you. So again, if you tune me out, if you're like, I got one way, Mr. Ware, I want to learn another way, just tune me back in here. You might want to use this way. It might be okay for you, okay? So, you got to look at all three of your terms here, and just think of anything that would divide all three of those terms. Just any number that divides all three of those terms. What's an easy one? Yeah, 2. Perfect. That's what I was hoping you would say. So what I'm going to do is I'm going to divide a 2 out. So I'm going to pull a 2 out front. If I pull out a 2, what does 12 now become? 6, and we still have x to the third, right? And the 4 becomes what? I pulled a 2 out, so it's 2x squared, right? And I'm going to divide a 2 out of the minus 8. It becomes minus what? 4x, right? Okay. I pulled a 2 out. That's great. That's a common factor, but it's not the most. Continue to look inside here. Is there any other number that I can divide all 3 of these by?
2.
Another 2. So guess what? I'm going to pull another 2 out. If I pull another 2 out, what number will I now have in front? A 4. Divide that by 2, it's 3. Divide that by 2, it's going to be a 1, so you can put a 1x squared if you like. And divide that by 2, it's minus 2x. Okay. Is there anything else I can divide all those 3 terms by?
1.
Okay, a
Maybe like a
1,
half?
but pulling out a 1 is not super helpful.
Like a half or so.
You could divide by a half, but we only want whole numbers for right now, okay? What about a variable? Look at variables.
X,
We could divide by how many x's?
X2,
X1.
Yeah, at most we can divide by x to the 1 because we're limited by this one right here, right? Yes, if we have x squared here, but there's only 1 x to pull out of here. So the most number of x's you can pull out from each one is 1x. So we'll pull it out, 4x, right? If I take an x out of 3x cubed, I now have what? If I divide an x from this, what do I have now?
3x2.
3x squared. If I take an x out of here, I now have 1x to the, well, not nothing, to the 1, or just you can leave it, right, 1x if you like. If I take an x out of this, what's going to be left behind? Just a minus 2. Can I take any more out from these 3 terms? So we found the GCF. It's 4x. That's the biggest thing that divides out from these 3. Okay? So in other words, you can take it piece by piece. You can take out piece by piece until you can't take anything else out. Because we took out 1, 2, and there's another 2 we could take out. So it was 2 times 2 gives us the 4 there. We had 2 2's in front, pulled in front.
I understand the question. So, and I understand this, but when you pulled out the 4, you went back to the original problem. Instead of taking the 2
No,
out of...
we took a 2 out of each one of these. 2 out of 6 gives us 3.
Okay.
Divide by 2, 1. Divide by 2, negative 2. And so it comes out front with that 2 and multiplies together to make 4.
Okay.
Same thing with the x.
I see how your reason was.
Yeah.
I felt like there was another step in there that you jumped over, but it wasn't.
Okay. No, that's good. Thank you for clarifying, just to make sure. Because I do miss things every once in a while. Okay, so for your assignment then here, I've got a worksheet with some practice problems. Okay. I would like you to do... Let's see. Okay. 1 to 19, every other odd. 1 to 19, every other odd. Do you know what I mean by every other odd?
That means like
You're really testing us here, Mr. Wedge. Every other odd.
Yes, every other odd. So you do number 1, then you do what was number 3? Skip it, and then you go on and do number 5, and then you skip 7, and then you do 9. Every other odd. So
He's
you
explaining
do
that
1.
to me when this is-
so we're not doing
1, 5, 9.
So we're not even doing
Yeah, 1, 5, 9.
Yeah, it goes 1, 5, 9, 13, 17.
And that's it.
That's it.
Shut up.
Sorry. Follow the directions on it. Did
I know.
Wow.
Anyone else not get
You're
one?
behind the other on track.
No.
Did you get this? 1, 5, 9, 13, 17.
You can use any method that you want, whatever's most comfortable for you. I'd suggest this one. Okay, this is the best one. Listen up, Alex. Shh. You can use any method you want for the homework. I would suggest trying to use this last one I just showed you, but if you get stuck, you can always fall back to this one where you expand everything out and then look for your groups. Okay?
Got this, Erica?
Sorry. Just be homework if you don't finish it. Yes, sir.
Say sorry.
Oh, I need to give Mark full credit for this.
Okay, I got it. Thank you, Miss Mulcahy.
Mr. Witt.
Dylan.
That's a beautiful voice
pulled an A out, right? So you should have 2A in front. You just have a 2. You missed the A. Do you understand? Do you understand what I'm saying there? No, Dylan?
No.
Okay, I'll come over it again. Hang on.
Oh yeah.
You see it now?
Wait, you want help me?
Yep. Who needs help?
Let's do it mine.
Okay.
Yeah, it looks like it.
You 8 divided by 2, right? You have to divide that 8 by 2. You pulled it divided to 8, so you
You
have
get
4.
4 so just A3 plus 4.
Yes.
So if we're using this last one, how is it? Because we can't take 2 families.
Yeah, you can. It leaves you a 1 behind. You divide. Yeah, exactly.
Okay, so we can just go.
So you go 2 parentheses. 2. You're pulling a 2 out, so 2 and then a parentheses. You pulled a 2 out, so you're just left at A to the 4th, right? You're factoring, dividing it out.
Ready to turn off that flash.
Okay, so then A to the 4th, and then divide 8 by the 2.
Turn it off. You think he's funny?
Yeah, it's hilarious.
So plus 4A, right? That's what you got.
He's crazy.
Yeah, I got you. Now,
My handwriting got real messy.
that's okay.
He's crazy. He wants to hurt my eyes.
Gentlemen, lower your voice. So is there anything else in common between these two terms? So you can pull, how many A's can you pull out in common? Just one of each, right? One of each. So you're just going to pull out one total. So 2A. Because you had the 2 out front. You're going to pull out an A now with the 2. It's 2A. And then, well, it's A to the 4th. If you take an A out of A to the 4th, you now have A cubed. Remember, it says, what is A to the 4th? It's 4 A's multiplied together. You take an A out, you have 3 A's multiplied together.